Well, greetings, class. I feel like I need a cool catchphrase to open up these videos, but instead of saying something cool and exciting, I'm going to talk to you about something called standard input output, standard I/O. Might not be the sexiest term in the world, but it's actually quite useful. So let's take a look at it. What this is best illustrated in the context of an example here. So let's imagine that you've got a program. You've got your program here. Okay. And we've got some data coming into a program, and that the program's spitting out some data. Okay. It almost looks like a function. We've seen some of these function diagrams in other places before where we have inputs coming into a function, outputs coming out. You could think of that at a higher level in terms of your program as itself can be doing that. And so we've got some input coming in, and by default, right, the standard input coming in is coming from a keyboard, right? This is the standard place in which you're having somebody typing in some information, and that information is coming and feeding into the program, okay? And then what's coming out typically is information being displayed to your console, aka your computer screen, right? So that's your standard input output, the devices that are there typically by default. Okay, but it doesn't need to be that way. We can change this such that our program has inputs coming from some other source. Okay, so what we're going to see with our program changing the source coming in is, instead of it being from the keyboard, right, we're going to change this to be coming from some sort of other location, such as a file, and that the program's spitting out something to a file, to some other other source. So what we're going to do is we're going to effectively, when we look at the input here, is we're going to change what is referred to as the standard input source. Okay, and we're also going to change the standard output source. Okay. And this is best illustrated in an example, okay? So I'm also going to show you how this differentiates from other programs you may have seen in the past, in which we were just simply having data coming in from a file and coming out from a file, okay? So if we look at this example here, this code example, okay, I'll run it in just a moment. But effectively what this is doing is, first of all, it's checking that the user has sent in a command line argument, thinking about what we've done in the past, where we looked at command line arguments. In this case, somebody's sending in a command line argument of the file name, okay, a file name. And this is similar to stuff we've seen in the past, right? We then are using that name of the file to open it for reading, checking that the file indeed exists. And if it does exist, we are going to spin the whole file. We're going to read the whole file integer by integer. Okay, and we're just going to simply print it to the screen. Then close the file and exit the program. All right, so that's a quick rundown of it, right? Let me show you the program in action running. It might make it easier to see what's going on here, right? I'm just going to compile it. We're going to go ahead and run it. Now, if I run it with no command line arguments, it's going to tell me I'm missing the command line arguments. Missing file name command line argument. That's this code here, the error checking here. Okay. If I run it with a file that doesn't exist, okay, could not open file fake.txt. That is this error checking here. Okay. And then if everything goes well, if I run it with a file that does exist, okay, I could see that there is a file called data.txt here, right? Just because there's some bunch of numbers in here, okay. So file data.txt does exist. I could come in here and notice I'm doing this without recompiling the program, right? That's one of the advantages of passing in command line arguments. I don't need to recompile the program. I'm just sending in different data, right? A different file name, just sending it in here. Okay, and that went, and all this does is it just runs through the file and spits out everything that's in it. So nothing too complicated. All right. That example I just showed you is stuff that you've all seen before, right? There's nothing new to that. All right. I'm going to add now one thing that goes beyond this. Okay. Instead of having this information come from a file like this, I'm going to have it come from the keyboard, right? And to do that, I'm going to use something called standard input. Okay. Standard input's going to allow me to remove all of these lines here. I'm just going to comment them out. Okay. And I'm also going to comment out the closing of it. Right. The only thing I'm going to do is change here. Instead of file pointer, I'm going to indicate that we want this to come from standard input. Okay. Standard in. STD in. Standard input. Okay. Instead of the file pointer. And what that allows me to do is now I got to recompile it because we changed the code. Okay. I'm going to now run it with no command line argument. And what happens is it looks like at the moment, it kind of looks like it's an infinite loop, but that's actually not what's happening. Standard input waits for me to send some information in. It's waiting. Remember we talked about before that by default, the standard input is a keyboard. This is the default, right? Now, we've used the keyboard inputs before using scanf, but notice there's no scanf in the code, right? There's an fscanf. There's no scanf, right? It's waiting from information from the keyboard. So if I put some information in here and hit enter, I've now sent that information into the program, and it's waiting for more input. Right, I could send some information in again, again, and so on, right? It's going to continue to wait for more and more input, right? So the standard input has been set, right? Standard input by default is the keyboard, right? This allows a program to just receive information from different sources. That's effectively what standard input is. It's receiving input from different locations, right? If I hit, this is a little bit of a trick, if I hit Control D, it indicates it's the end of the stream of data, okay? And it'll end the program, right? That's like kind of hitting like the end of the file. Control D will do that. Indicates the end of the stream, okay? Now, one advantage of doing that is I can do something called file redirection here. And what this little less than symbol does is indicates that, hey, instead of the standard input coming from the keyboard, we're going to send in the data stream of this file, okay? That will automatically open the file, right, for reading, right? And the program will then process the file until there's no more information, okay? Notice the program does not have any logic in here indicating that it's opening the file or anything else, okay? Go ahead and run it. It processes everything till it hits the end of that data stream. It hits the end of it and it's done. Okay. That is this little symbol here, the less than, right? You can think of it as taking this data and it's like pointing it, it's sending it into that program. Okay. Right. Now we've changed the standard input from being a keyboard to being a file. Okay. Now the advantages, I think it's important in terms of remembering this, is the advantages of doing this, right? One big advantage is I could send information into this program from various different sources, okay? This program, without recompiling it, allows me to send in information from different files, okay, as well as from the keyboard. Just depending on how you call the program itself does not care where the data is coming from. Right? You could send information into it from different sources. You do not need to recompile it. You just have to indicate when you're running the program, when you're running the executable, where the data should come from. And by default, it will be the keyboard. Okay, that's standard input. Okay, standard output, see all this data here is all coming to standard output. Standard output, as we indicated before, is by default goes to the console, goes to the screen. By default, it's being displayed here. Okay, if I do this, notice I did this greater than symbol out.txt. That takes all of the information that would be displayed to the console, and it actually sends it that standard output information. All this information that would go to the console is what we consider the standard output of the program, and we send it into this file. Okay, it will automatically, right? This is also file redirection. Notice the different symbol. It takes the information generated from this running this program and sends that output to that file. It will automatically open the file for writing and send that information in there. Okay, so when I run this, it looks like it did nothing. Okay, it looks like it did nothing. However, if I open up that file, out.txt, we'll see that the information is actually sitting there. Okay, it automatically, by calling it that way, took that information and sent it to where we wanted it to go, in this case, to a file. Okay, so just to recap, remember, standard input-output, right? It's by default, the device is the keyboard for input, the console's for output, right? Oftentimes we want to change the standard so that we can have programs that can receive information from various different places. The program itself does not need to be recompiled. We can send in information from different places, whether it's from a file, a keyboard, or it could actually be other sources as well, without actually having to make any changes to the programming logic. And it's the same thing with the output, right? By default, it'll go to the screen, right? Sometimes you want to send that information to different places, right? In this case, we're showing an example where we send it to a file, right? When we're calling the programs, we can use file redirection. The less send symbol takes some information like aka from a file and sends it into the program, right? The greater than symbol will take the information generated from running the program and write that to a file. Okay, very powerful concepts. We will use them in here. They're very good to see. They're very useful, and these are concepts that kind of come up in different places, just in terms of just building systems and writing programs, right? Oftentimes, right, a big part of it is you want to separate the logic of the program from where the data, how the data is coming in and how it's coming out, right? Focus on the logic, and then the information coming in can come from anywhere, and where it's going when its output can go wherever it's needed, right? Keep that logic separate. You avoid these dependencies that can be pretty nasty when you're building more complicated systems. Okay, we'll practice like always, right? And we welcome questions. So feel free to rewatch if you need to have some additional practice. And there's also some prerequisite videos related to files and file I/O. And if you can always go and watch those, or reach out to me if you need some additional background information to be successful in understanding the program that we just looked at. So thanks for watching, and I will see you soon.